All right, so in this video, we're going to take a bit of a divergence from the sort of source material that we've been covering for the better part of the semester. Early on in the semester, we sort of established what were sort of the two core economic ideas behind most of the environmental problems that we're going to discuss in this course, negative externalities and public goods, including issues related to tragedy of the commons and things like that. And then, of course, we did a deep dive into issues related to pollution and spent a lot of time sort of defining pollution, as well as discussing, what are the aspects of certain types of pollution that we want to be aware of and be cognizant of when we set policy. And, one of the things we learned was that it's very context specific, that policies that we want to use for particular pollutants aren't necessarily useful for other pollutants for various reasons. And so policy needs to reflect the variation that exists in terms of both the range of pollutants and also the range of potential solutions. And that includes both command and control policy like standards, mandates, as well as market-based solutions such as Pagovian taxation or cap and trade programs. Or one of the things we'll discuss in this video is another type of market-based mechanism called a catch share program that may reduce the unsustainable nature of many fisheries. So let's jump in. Just like pollution, we want to spend a little bit of time defining some context and some concepts. So a sort of resource taxonomy begins with a conversation about the notion of reserves. And this is one of the more complicated aspects of resources, is because typically when we think about reserves, we sort of conjure in our minds, things like inventory, like an amount of a resource that we have currently. It is our reserve of that particular resource. In fact, the United States has set aside an amount of oil, which it calls the strategic oil reserve. And that represents an amount of oil and gasoline that's been set aside and tapped into for national emergencies, things like that. But in the context of environmental economics, we have very specific uses and different types of resources. So current reserves are reserves that we know about. We haven't extracted all of them necessarily, but we know about them. So they're sort of extracted reserves plus the reserves that we know about that can be extracted. That's a real interesting distinction that when we talk about resources is very important, is that primarily we think about resources in the context of extraction and in the context of, are we able to get it out of the ground physically? But one of the things that we'll talk about in this video is that another thing that factors in significantly to the decision of whether we pull a resource out of the ground is the economic feasibility of pulling that resource out of the ground. Potential reserves is a broader category. It sort of also includes those reserves that we may or may not know about, but we, at this point, given current technology and or current economic conditions, these reserves cannot be extracted. And this is a complicated sort of notion, because the truth is that if we take sort of a longer time horizon into consideration, the idea of potential reserves becomes almost more like a mathematical function. Whereas current reserves is just a total amount, it's sort of an additive aggregate number, whereas potential reserves is going to be determined by a number of different indicators, and so therefore is more like almost a mathematical function which describes what we have in terms of potential reserves. And then we can think about sort of the resource endowment as being the total sort of earth stock of a particular resource, or if we want to think about that regionally or sort of even subnationally, we can think about the United States having its own resource endowment, or even the state of New York having its own resource endowment, or we can think about resource endowments in a more global way. Just to kind of give you an idea, this is two figures which show proved reserves in oil as well as natural gas. The term proved here refers to the fact that we know these reserves exist. So we may think about them in the context of current reserves, although sometimes we know that a reserve exists, but it isn't necessarily extractable. And so Again, it becomes sort of difficult to delineate between current and potential reserves, but I would say that proved reserves are generally speaking what we would consider current reserves in the context that we know they're there, as well as we know to some extent what would be the economic cost associated with their extraction. Another way to think about this is in sort of relative to where the resource is relative to the Earth's crust. Again, sometimes we may think about these issues from a more complicated standpoint, but in reality, when we talk about resource extraction, it's very important for us to understand that the closeness that a resource is to where we are, how far it is into the Earth's crust really matters, because of course the further it is, the harder and more expensive it is to extract. And since we will think about reserves in the context both of their feasibility in terms of the technical aspects of their extraction, can we scientifically extract the resource? Do we have the necessary technology in order to do that? But in addition to that, is it economically feasible to pull that resource out of the ground? And the further and further you go down to the ground, of course, the less economically feasible those resources tend to be. An example that I'll bring up, more than once in this particular video is going to be about, the difference between Middle Eastern oil, which is cleaner, it's cheaper to refine, it's easier to get at, it's much more near the surface, and then juxtapose that with the Canadian tar sands oil, which is much deeper into the ground, it's dirtier, it's more expensive to refine, and so relative to certain economic conditions, Canadian tar sands oil may not necessarily be considered a feasible reserve of oil resource, just because it simply isn't economically feasible to extract. And because extraction happens almost always by private industry, therefore the amount of the resource that ultimately makes it out of the ground is going to be based upon a profit maximization perspective. And so for the most part, reserves that are not economically feasible aren't pulled out of the ground. And so we don't necessarily consider them in the total stock of the available reserve. Now, again, market conditions can change. So in the 1980s, we knew about the Canadian tar sands, but they were not economically feasible to extract. So those were not counted into the idea of current reserves. Over time, however, as the price of the oil on the global market rose more and more and more, it became economically feasible at that point to then extract those reserves, and they became part of the current reserve that we think about. So we want to think about reserves. We want to think about resources as sort of existing on the spectrum between identified and then speculative, meaning that we know they're there and we know exactly where they are and how we need to go about getting them. And then sort of all the way to the more speculative side. And within this conversation, economic feasibility really matters, because even if we have identified a particular reserve of a resource, whether or not that is sort of considered current, it comes down to whether it's economically feasible to extract. So now we want to sort of think about resources in the context of how their natural processes exist within nature. So there are depletable resources which are not renewable in any reasonable time frame. In other words, we as humans can't think about them as a renewable resource. And so oil, natural gas, a lot of your minerals and your metals, that the creation of which occurs over millions and millions of years. And so within any, sort of reasonable context of time, we cannot consider them renewable, right? So, I mean, in a sense, will one day become oil, just like the oil that we pull out of the ground now once was the dinosaurs, but we can't think about ourselves and our carbon that ultimately creates that oil as a part of our resource stock. And so depletable resources are resources for which we don't think about them as renewable. Some of these resources can be recycled, however. For example, aluminum, certain types of metal. I mean, even oil to a lesser extent can sometimes be recycled. So you can process oil into gasoline and refine it, and then you can take the sludge that comes off of that refinement and you can use it for other things. In fact, when you go to an automotive repair shop and you buy, oil, that oil that you're purchasing is oftentimes oil that came off first of a gasoline refinement process, and then that oil was slightly more refined and became motor oil at that point. Obviously, this depends on types of grades and things like that. But even things like oil can be somewhat recycled. And of course, there are other depletable resources that have very little recycling value. The important thing about recycling is that first off, recycling can never be 100%. The idea of entropy exists, just like when we talk about coal ash at the beginning of the semester. When you burn coal, it doesn't just go away. Its energy is simply transferred. That's a very similar idea to the notion that depletable resources are, even if recyclable, cannot be recycled 100%. But the biggest concern with depletable resources is the issue of exhaustion. The idea that we exhaust the resource, and if it's an economically important, socially important resource and we exhaust it, this is problematic for a number of reasons. On the other hand, if we have an exhaustible resource, it's important for us to understand potential substitutes for that resource if and when we start to fully exhaust that resource as well. And the issue of storage is really important. So if this is a resource that can be extracted and then stored, then this, of course, increases our ability to sort of deal with cyclical demand changes. Just like I was previously talking about with the U.S. Strategic Oil Reserve, where we've literally put away oil to be used and gasoline to be used during times of national emergencies. Storage of depletable resources is really important because we can extract the resource and we don't have to use it immediately. We can store it and keep it for a rainy day, so to speak. Like I said, it's really important that we, throughout this conversation, keep in mind the economics. And actually, at the end of the video, or at the end of this lecture, rather, we're going to go through some basic economics. And that way, when you have thoughts and conversations about resources and the economics of resources, you'll be equipped with some basic economic analysis tools that will, inform you as to what is likely going to be the future behavior of a particular resource, whether it's something like oil or natural gas or cobalt, again, whatever it is, food, water, so on and so forth. So this is just a graph which shows the historical oil price for WTI crude. And so, again, you can see that there's all these sort of small cyclical changes that occur. This is 2011 through 2020. And then you'll also notice there's these big dives around 2014, 2015. This is an oil price war that occurs because in the mid to late 2000s, what you have is the United States is dramatically increasing its production of oil, its extraction of oil. And as a result, what this does is it puts supply pressure on the global oil price. It starts to put downward pressure on it. And then in 2014, OPEC, along with other non-Western oil companies, engaged in what we call a price war, where they took existing reserves of oil and they thrust them onto the market. And combined with the increases in supply that was coming from U.S. domestic oil sources, this, of course, pushes the price way down. And at first, this is sort of, to some extent, and to many people may seem like, well, oil companies are putting their oil onto the market. It means that they're sort of, likely making a lot of money. But the fact is that when they do this, the price that they get for a barrel of oil plummets. And as a result, profits decline. So the reason why we call this a price war is because oil companies are on purpose reducing their short-run profits, because what they're trying to do, in a sense, is get the other side of the price war to disarm, what we call unilaterally disarm. So OPEC wants Western oil companies to stop putting their oil on the market as much. Western oil companies want OPEC to stop flooding the market with their oil, and it becomes this game theory process where neither of the two sides want to stop. And you can see that this price war continues for nearly 2 years. And it wasn't until the latter parts of 2016 that we saw any sort of increase in the spot oil price of oil. And then you can see that there's been more declines. So we're in a period now globally where there's just a tremendous amount of supplied oil already kind of in the market and into things like the strategic oil reserve in the United States. And so this is one of the reasons why oil prices and gasoline prices are actually sort of historically low if you consider the last 20 years. You can see that this is U.S. Fuel imports and exports. The red line is exports, or I'm sorry, imports. So this is the U.S. importing fuel into the country, and then the blue line is exports. You'll see over time, the U.S. has always exported less fuel than we imported, but you'll notice that has changed recently. Again, in the late 2000s, the U.S. really started to ramp up oil production in the U.S., and in fact, around 2015, 2016, the U.S. becomes a net fuel exporter, meaning that we actually export more oil than we bring into the United States, which, I think perhaps to a modern student, this doesn't seem like that big of a deal. You may actually think about the U.S. as an oil producer, but this has not historically been the case. So this is a real shift, a real tonal shift in the global oil market. And as if you go back to this, you can see that it's created a real almost dichotomous situation in which there's before the U.S. really entered the global oil market, and then there's after. And in many respects, we're probably not going back to that previous world. And again, you have to understand is that because the oil price is now lower, this means that a lot of your hard to get at oil reserves, again, those sort of Canadian tar sands oil reserves, some of those are no longer economically feasible. And so I remember back in 2017, 2018, you had companies like BP and Shell who were planning these expansive oil extractions off the coast of the United States, also sort of near the Arctic and because oil prices plummeted, they canceled a lot of those leases. And so they had made plans to extract the oil, and then when the oil price plummeted, they got rid of those leases, in part because they sort of foresaw that the global oil price wasn't going to rebound anytime soon. And then, we have resources like coal, for example, which, coal has been sort of slowly becoming less of an important resource in the United States. This is just for the US. Of course, in other parts of the world, coal is still really important. For example, China has only very recently started to kind of stabilize their coal extraction and usage. In the United States, we've sort of had this steady decline of coal over time. And again, this is not because we don't have coal. In fact, we have quite a bit of coal still left in the ground that is never going to be dug up, in part because we are now seeking substitutes for electricity generation, namely natural gas, and of course, your renewable sources of energy. And so again, what you can see is that the behavior of resources, both in terms of how much gets extracted and what we use those resources for, it's really going to be impacted not only by the resource itself, but what's going on in sort of the broader economy and what's going on in the context of substitutes for that particular resource. It's really important that when we talk about resource economics, that the idea of substitutes, are there resources other than this particular resource that you can use? So when it comes to energy production, coal, natural gas, oil, nuclear energy, renewables, these all become substitutes for each other. And so all of the markets that those products exist in are going to ultimately affect, what it is that we're using for electricity generation. Here's a table for cobalt extraction by country. You'll notice specifically with China, China is extracting far more cobalt more recently than they have historically. Cobalt is an important resource for computer chips, namely for smartphone technologies. And so, the global demand for cobalt is rising considerably. And if you look at most countries on the table that extracted cobalt, you've seen increases. There are some decreases, but you're seeing namely increases in terms of cobalt. So the demand for cobalt rises, and so countries are responding, companies within countries are responding by extracting more cobalt. It's a very, very basic economic story. Here's uses of aluminum over time. So you can see, what we use aluminum for and how that has perhaps changed. There's a lot of sectors that use aluminum, transportation, packaging, construction, so on and so forth. And again, this just gives you an idea of what we're using aluminum for. And then therefore, when you have conversations about a resource such as aluminum, you understand that there's not just the aluminum market, but there are the markets for goods and services that use aluminum as an input. The thing about resources is that they are generally inputs in some production process. So metals are not final products. They're used as inputs, what we call intermediate goods, to be used in the production of final goods. The same thing with oil, right? Oil is not usually a final good. It's refined into gasoline. And so it's an intermediate good in the production of gasoline. Iron ore is an intermediate good used in the production ultimately of steel manufacturing. And then even steel itself is also an intermediate good used in automobile manufacturing, construction, so on and so forth. And so when we talk about resources, it's not just the markets for those particular resources, but all the other markets that use that resource. Those other markets are going to have an appreciable effect on the behavior of that particular market. Beyond depletable resources, we of course have renewable resources. In the context of renewable resources, the issue is we want to keep clear sustainability. In other words, we want to extract these resources in a way that allows the natural replenishment rates of nature to be kept up. So even though the resource is renewable, it certainly can be depleted. So that's one thing that's really important that we understand about renewable resources. Be it water or forests or food, such as fisheries, or even livestock. These are products that can be renewable as long as we are not harvesting them at rates that are beyond nature's ability to replenish them. So sustainability is the key. We want to think about things in terms of the flow of the resource. So how much of the resource is being consumed on an annual basis? And then, of course, we want to ensure that that consumption and that processing of the resource is not being done at a rate that is unsustainable, that will cause an exhaustion of that particular resource. For some renewable resources, flow is very unimportant. Solar and wind, these are not sort of cyclically year to year things that we're concerned about. There's not less solar, there's not less wind energy over time. But storage is very important. Not just for your solar energy and your wind energy, but for things like food and water, right? So these are food and water, especially, are resources that can be harvested and, in the case of water, extracted, and then can be stored. And again, that storage smooths what we would call the cyclical imbalances. So for water, for example, we want to make sure that we have fresh water on hand in case we experience droughts. In the context of solar power, we want to have battery technology that enables us to store that energy so that, for example, on cloudy days, when you have that cyclical imbalance, there is energy that can be used so all the lights don't go out. That historically was a big problem with solar energy, by the way. I mean, it kind of becomes a joke now. Oh, there's a cloudy day, we're not going to have solar. But the old technology of solar power, it's sort of only been recently where we've actually created batteries that have the capacity to store, non-negligible amounts of solar energy. Here are two fish stock population dynamics over time. Both of these are off the coast of New York State. So bluefish is a economically important fish for fisher companies off the coast of New York State. And the same is true of cod. But you'll see that there is a particular behavior to cod, which is that it used to be caught in high volume, and then over time, it is now no longer caught as much. Some of this has to do with the fact that there is less cod in the waters immediately off the coast of New York. Some of that is for the changing water temperatures that's occurring because climate change is changing the habitats. But then in addition to that, you also have a situation where there's a lot of evidence that all of this cod landings that occurred in the 50s, 60s, and 70s exhausted the resource to the extent that over time, we're just not seeing the same replenishment rates. With bluefish, we haven't necessarily gotten to that point yet, But you can even see that in the context of bluefish, there's this decline in the last several decades as it pertains to the commercial landings. Uh, Bluefish is a regulated fish in New York State. It's regulated by the federal government. So the federal government actually limits how much bluefish a state is able to catch each year. And so that's probably one reason why you've just seen the steady decline as opposed to this dramatic decline with cod. So cod had very little protections historically, and so has been fished into extreme exhaustion. Whereas bluefish, because we've regulated its catching a little bit more, it's had a little bit more of a steady decline. Now, who knows? Climate change may cause the ultimate, the New York State bluefish landings, that is caught fish. It may cause those to decline over time and certainly get lower, but we're not seeing that sort of much. But we do see that behavior with cod. Here are battery technologies with respect to solar. We can see over time that batteries are becoming much more able to store amounts of solar power. And this is just general batteries, so not just for solar, but certainly solar is a part of this. So over time, we're able to store more sources of energy, solar and wind, and this will make those sources of energy more viable as it pertains to electricity generation. The problem with those sources of energy with respect to electricity generation, of course, is that with coal and natural gas and nuclear, there is little to no need to have any sort of storage, right? You burn it, you produce the electricity, and then boom, it kind of keeps that flow. With things like solar and wind, again, there's those cyclical imbalances that we have to be concerned about, and you need an ability to store solar and wind energy. In fact, what happens with solar and wind is that when it's bright and sunny, you're actually producing more solar than you need in that time period. And then, of course, at night, you're producing less solar energy than you need. And so just the ability to simply carry over some of that excess solar energy from the day to the nighttime is very important. The same thing with wind. And then, of course, there's also the issue of water. In the United States, we're fairly lucky that there are not that many water problems, with the exception of cities like Phoenix, which you see here, which is dealing with a substantial concern caused by drought conditions, which have been getting worse in recent years, at least partially due to climate change. But then in other parts of the world, water issues are much more pronounced and much more concerning. Yemen sort of famously has a tremendous water scarcity problem, and this water scarcity problem has been blamed for a lot of the political and social unrest that exists in the country of Yemen. And I think that's, to sort of wrap up this conversation about resource taxonomy, is that we can kind of define resources in very specific ways: renewables, depletables, recyclable, depletable, recyclable, renewable, so on and so forth. It can always give definitions to various types of resources. But at the end of the day, what we're concerned about is the harvesting, is the extraction of these resources, is the consumption of these resources in such a way that there is an addition to sort of stability over time. Think about electricity. Electricity has added a tremendous amount of political and social stability over time, right? Because the more access people had to electricity, this improved both business and at home life. And so this is good. People need electricity. Juxtapose that with, again, going back to the water issues in Yemen, which cause these sort of social and political problems, the absence of water. So resources are extremely important to maintaining the social order. So beyond an environmental issue and beyond just the sort of scientific definition of a resource, resources almost always carry with them tremendous social and political issues as well. I mean, if you just look at the sort of presidential campaign historically, issues of coal and oil and the environment, of course, are prominent in these conversations. And so the issue of resources goes beyond the economics of resources and really needs to go into, okay, how do we think about resource extraction in a way that understands the economics so that we can make policies and make plans to ensure that the resource adds to social prosperity and the lack of the resource doesn't take away social prosperity.